Yeah, thank you everybody for coming. Nice to have you here, Simon. I'm Stefan Jaksik, and I'm part of the board of the ULT, and we take care for clean and dry environments. We are here at the Fraunhofer IWS, specialized on laser techniques and also on certain battery technologies. Since I would say 15 years maybe, batteries is one of the core competencies of this Fraunhofer. Fraunhofer IWS is here on a Fraunhofer campus. Many Fraunhofer institutes are here. And together with you, we had the chance to support you with a dry room project seen here. It's a very sophisticated dry room, a dry room which measures all parameters, can easily adapt to new technologies, and especially in the research environment gives great freedom and supporting what you need on that certain day for your research.
So also from my side, welcome and thank you for being here. Yeah, it's true, 15 years we are doing battery research here at IWS, between material research, but also process research, and we end at the prototype cell level. And what we do is we are focusing on specific topics for next generation batteries, but also in terms of processes for the current lithium-ion technology. And this is what we are doing, especially here in this dry room. We are working on the so-called dry battery electrode technology. So coating a battery electrode without using solvents. The traditional process uses the slurry preparation and the slurry coating step, and so active material binders and carbon additives are mixed and then coated on aluminum foil, and then this has to be this wet film has to be dried, and this consumes a lot of energy, a lot of space, and we are working on technologies avoiding this step of drying, because we can work, or we can make an electrode out of the powder and get into the final electrode. And this is where a lot of research is going on at the moment. We are working from the powder and make the electrode out of the powder. So this is why we need this kind of laboratory, which on the one hand side can handle dust and powder materials. And on the other hand side, the materials we are using are sometimes humidity sensitive. So we also have to regulate or control the ambient atmosphere in the laboratory. And this is why we work together with ULT to design and find a good way to operate this dry room.
So I think the great story behind it, that you remove from the process of battery cell manufacturing, you remove process steps. I think not just one, probably 2 or 3 once it is working, which saves a huge amount of money in producing, because less process steps means potentially more yield, less potential for failure. So this is money saved. And you mentioned what is the dry room for. When we remove particles and when we remove the moisture from the line, we make the batteries much more reliable, or just even working. Because the great challenge with battery cells is, and something very new for me as well, is if you are not controlling the environment right, you see the failure not after production, but probably just in the field. Because a particle in the battery could be the incubation point of future shorts. And humidity in the battery cell is not a problem for a standard phone battery, because we give the phone away after a few years. But for a car battery, it's a big problem, because cycle life depends on humidity. Battery cell manufacturing is, for us as ULT, one of the important clean tech products, where an environment really determines yield, ramp rate, and hence money, economical success of the company.
Yeah, and for our research, I mean, it's not only focusing on a specific material or specific process step. We are a research institute, so we have to cover processes and developments which starts in the very early stage. low TRL, new materials, everything has to be adjusted and adapted in the processing, in the mixing, and so on. And of course, we also need a lot of analytics too. So this was also a challenge for making this dry room, because it's actually one dry room, but there are two laboratories inside which have to be controlled independently and separately. And I mean, we are not a producing industry player, we are a research institute, as I said. So for us also, it's very important to monitor and to control energy consumption. This is also very important here, and the interfaces of the dry room allow our technical services here to control this, and also to operate the dry room only at low dew points when it is needed. It's a very short time coming from regular ambient environment and drying down to minus 55 degrees C in a few hours. And this is a big advantage for us, cost saving in our research work as well. It gives us a lot of flexibility in what we are doing inside, so we can look on smaller scale developments, but also on large scale roll-to-roll electrode manufacturing.
Can you show me around, like what you are researching here exactly?
Sure. So let's have a look in our dry room. Here you can see the colleagues working in this dry room. You can see it's separated basically into two sides. This is our process chamber here. We have the one side where the coating activities are done and one side where the mixing is done. And for the mixing we have different tools. It's Irish mixing type, high intensity mixers. And on the other side we have kneading and extrusion type of mixing. And those mixtures are prepared in a dry state. What comes out is a dry mixture, which then can be used for the coating process, which happens on the left-hand side. We have a calendar type of setup there, various rolls, and we feed the dry mixture into this coating tool, into this calendar setup, and can manufacture electrodes from the powder directly into the electrodes. And the nice thing is, directly behind this process chamber, we have the analytics chamber. So we can do processing here in the front and hand over to the colleagues from the analytical team the samples to analyze them directly, to get direct feedback from what we are doing in the development, and see what are the properties of the powders or the electrodes. And this is what we can see on the other hand side. Okay, the colleagues here are making the powders, as I said, and when necessary, those powders have to be characterized in terms of powder rheology, particle size distribution, electrical conductivity, and these things. And this is something we can see in the back of the chamber. So here we can have a look into the chamber where we do the analytics. We do powder analytics on the one hand side, but also electrode analytics. For the powders, it's very important to analyze the way how the mixing was done. And we can see a proper mixing from two aspects. We can see it from the powder rheology, but also from the conductivity. The conductivity comes from a proper distribution of the conductive additive. And so we can give a direct feedback from the colleague measuring here the powder to the mixing colleagues. And the same is true for the electrode preparation. A proper adhesion gives good feedback on how well the film formation was done. And those are the steps which are used here to give a direct feedback for the development. And of course, later on, the battery cell testing is also carried out, but this happens in another laboratory here in our institute. Okay, now you understood what we are doing here at IWS. in terms of dry coating and dry material handling and electrode preparation, but I think it's also interesting for you to understand how the dry room operates, and therefore let's talk again to the colleagues from ULT.
In order to achieve very good controllability of this cost-effective dry room, we put all our know-how for mini environments into the technique. And Florian Mathieu, our head of project management, was also the head of this project, and he can best explain what we did here. So Florian, maybe you walk us through the technique here.
Thank you. What we see here is our air supply system in the technical area with a very small footprint. We have an DHU and also an air treatment system, but maybe let's get up the stairs and see at the details. Now we are at the technical area and see all our air treatment system. First we have here the filter unit. In the room we capture all pollutants and bring it here to treat the exhaust air so we can ensure the technical cleanness in the process. And we have the possibility to recirculate all the other air, and that leads to big operational energy cost savings. What we see here is our pre-cooler that cools down the air to a certain level of 10 degrees, so our air dryer can concentrate on lowering the dew point without having a lot of moisture inside. This is our first dryer that dries the fresh air. We need to have the right oxygen level in the room, and this dryer dries the fresh air to a perfect level before the recirculation air is mixed to the first cooler, and this cooler brings down the whole air amount to 10 degrees again before we go inside our main dryer. And this dryer dries the air down to a dew point of -70 degrees, or the dew point that the customer needs for his process. This is a very flexible system, so we have all the time the right air condition that the customer needs for his process. This system is very flexible. The customer has the possibility to monitor all measured process data and can easily set up the target values. This gives the customer the opportunity to easily adjust all process parameters and can quickly change his process technology. That means he has the possibility in one part of the room to have a dew point of -50 degrees, and in another part of the room even ambient air at the same time. So this leads to massive energy savings and lower operating costs because he has the air condition he needs really for his process in the right time.
Hello Simon, welcome to ULT. We are very happy to see you here. This is our headquarter of ULT AG, our manufacturing site, research development, sales, all the units you need for a company are here. And we soon will have a walk through the company, through all the manufacturings of our units, and go into the depth of our technology. So this is our office area. Further offices are in that direction, and everything is designed to be very open. We are a company which takes care for clean air, and that's why we have a big window showing the wonderful blue sky. And we are organized in a special way for supporting our customers, strongly market focused. So all the teams which work on customer topics are sitting here, and they are a salesperson, and a technician, always in combination on these topics. And once we get an order or we do a cancellation for our customers, it comes to the project team. They finalize the whole project and bring it then to production. So let's go to production, and our head of the project team will show you the details. So this is the area where we finalize our project, bring everything together and make final test. And I want to introduce you to Florian Mathieu. He is head of our
Nice to meet you.
project management and most experienced to explain you what we see here.
All right.
Yeah. So this system shows very good competence we have at ULT. We have a very deep process know-how, and so can develop systems that really fit with the customer needs. So we know all about filtration and air dehumidification, and this system combines both. So we have a filtration unit, and after this we have our dehumidifier and a post cooler, and so we can ensure product quality by having very good air conditions with depending to particle cleanness, air humidity and temperature.
So if you want to go more into the details on how we manufacture everything,
Yes.
we can make a small company too, if you like.
Great.
Okay. As a company which takes care for filtration, we also take care for filters, for sure. So the majority of our filters are standardly manufactured in high industrial processes. But you also have a part in the company where we work on very specialized filters uniquely made for certain processes. And these filters are customized on that area here. And one of our main promises to the customers we give is that after our filtration, he can breathe the air and it's healthy, independent on what was on the raw gas side. And therefore, we test all of our filters, every single filter. And you see it, for instance, on that filter here. Every filter gets a certain test stamp, qualifying it as in order. So this is a base, and on top of this, we do the finalization or the customization of all the different materials we need. So for sparks and gases, coarse dust and fine dust, everything will be stacked on top of this tested filter in order to ensure that everyone lives healthy and in a good atmosphere. So that was the filter manufacturing. Let's move on to the finalization of our machines. These are our production lines or production places, all of them designed regarding to lean requirements. Here we have a standard manufacturing, everything on one place for one of our mobile filter units. This kind of filter units manufactured here on battery cell production, for instance, in the welding process or in some laser annealing processes used. And going further to the next line, this is a line of a modular system. We tend to work in platforms or modular systems in order to be customizable, but at a very good cost factor. That's our unique selling point, giving customized solutions at a reasonable cost factor. And what you see here, you find in the process, especially in soldering, laser parts of the process, marking, for instance, if you want to follow the products or give them product information on the cells. So that's done here. And this is our third production line, and this is used at the moment for tools for additive manufacturing, also a significant part of our business. So battery and additive both needs very well controlled environments in order to have yield and good quality products. That is our topic on the market. That's what you see here, but you also can use it for different kind of process steps. And then when you look at this, on every line we have our shop floor meeting where we on a day-to-day schedule check if everything is alright, if the product quality is in line, and also the production speed is according to our needs. So this is a typical, very typical unit for battery cell manufacturing. In most of the battery lines, we find this unit nowadays because it is very capable to capture all these hazardous dusts which are exhibited during production. So we have a spark separator, we can have self-cleaning, long-lasting filtration for the dust. And here, finally, we have another second steps of filtration. One is for the fine dust and the certified filtration, which I showed you in the beginning, and also activated carbon to remove chemicals from the air. So anything which is exhibited during a production can be filtered by that in order to make it very safe and secure. It is explosion proof and made for very long endurance filtration. In that area we have the final test area. Everything which is produced during the day comes to that area, gets its final test and goes then to packaging and is shipped to the customer. And well, I think that's the meaning of excursion. We just can explain what we see at the moment. What you see over here is a very typical filter unit made for battery cell manufacturing, the big one. This goes really into cell manufacturing. And this goes really into cell manufacturing. It is an explosion secure system, and it allows OEB-like filter exchange. That means even the service personnel and everyone is always very secure, because as you know, some of the battery materials are very hazardous to life, like NMC. And with this system, customers are always on the safe side.